Hi there, I'm back again. Okay, I'll try to be very slow on this one. This one is on Seco theorem. Seco. Let's hope this is a correct spelling. Seco theorem. Now there are a lot. I think I'll need a video where I'm going to explain all of them from one up to. In fact, I think there are 12 in total, but the only important one that we're going to look at in that video, the future video, will be just 7. So this one is made up of all theorems that are there. So let's see if we can get the sense from this whole question. So we have the circumference of the circle here, or we have the circle rather, and on the circumference of the circle we have these points. We have P, Q, we have P, R, Q, then the center we have O, then we have a tangent A, R, and B. So it will be a bit difficult to follow along this topic because I assume that you haven't yet known all the theorems that are there. But just mention of what I'm seeing here. First of all, we have two radii coming to the same chord. So when two radii from the same center comes to the same chord, it means they're going to form an isosceles triangle. Sometimes it can be made to be this an isosceles triangle, other times it's not. But just know that, just try to follow them from the center, this one here, from here, and this one here. So they are meeting this chord. Each of these radii is meeting a chord at the same angle as this one. So it means that if we know the size of this angle, when we subtract it from 180, because this is a triangle, we subtract it from 180, whatever answer we get, we have to divide it by 2 so that we can share those angles to these ones. That's what I can say from here. The other one again I can say is that this is a tangent. A tangent is a straight line which touches the circumference of the circle at one point. So this whole line is touching this circle at one point here. So the radius, the angle between the radius and the tangent is always 90 degrees. So from here all the way up to here is 90. Likewise from here all the way up to here is 90. What else am I going? What else can I see? Oh yeah. Okay. Yeah, the angle at the center, when subtended to the circumference, it is twice the angle at the circumference, or the angle at the circumference is half the angle at the center. So again, for this one, what I want you to do, you have to trace these two radii again. You trace this one from here up to point P there, trace this one also up to point R. Now, have you noticed that again, after making a turn, they've met somewhere? Where? Not here, but here. You've seen where they've met. So this one after coming here, it went there. This one after coming this side, again it went there. So they've met here. So there's a relationship that exists between between this and this angle here. So this is the angle at the circumference, and this is the angle at the center. So the relationship is that this angle and this angle here is half the angle at the center, or this angle here is twice the angle at the circumference. I think with those three, I think we can go on now. Just go and hit it. Okay, let's find the angle OPR. OPR. This angle here. What is the size of this angle? Okay, first find the size of this angle. I think what will help us is the size of this angle here. And what is the size of this angle? Remember that this angle that you are seeing here, angle O, let's say angle ORA, it's a tangent. It's an angle between the radius rather, and of course the tangent there. So it's 90 degrees. So since this side we have 140, we have 44 rather. So this angle here is going to be 90 minus 44. Or if my memory serves me right, I think it should be 46 as the answer. Yeah, that 46. So this angle here that you are seeing here, it is 46. So, and we said when two radii coming from the same center goes to the same chord, they have the angle at which they are going to meet the chord will be the same. So if this is 46 here, and also this one here is going to be 46, angle OPR. Angle OPR, now not this actually, it's this, the whole of this. Angle OPR, so it is 46. So OPR is equal to 46. Which reason can we give? I can say can I say angles going to the same chord? Angles angle, I think angles in an isosceles triangle, yeah. Angles in the base of isosceles. Isosceles triangle is a triangle that has the base lines to be the angles that are coming from the base going to the same point to be the same. So an isosceles triangle. I think this is the reason we can give, right? Yeah. Then angle PQR, angle PQR, this angle here, angle PQR. So remember, what can help us to find this angle? We're going to use that. We're going to use the theorem that states that the angle at the circumference is half the angle at the center. So now we have to find this angle here at the center. What could be the size of this angle? Remember we said these angles are the same, right? And this angle plus this angle plus this angle, they make up a triangle which adds up to 180 degrees. So when we add this plus this one, should be able to get 180. So we're going to have 46. We'll have 46. My work is dating. 46 plus 46 plus, let's call that one as angle we don't know. I don't know why x suffers, and it's the one which is in my hand right now, is equal to 180. So this one is going to give us 90. Is it 94? Oh, 92 rather. Mathematics. 180. Then we have x is equal to 180 minus 92. X is equal to 88. So this angle here is 80. Remember, this is not the angle we're looking for. We're looking for this angle here. So now, yeah, these lines, when they met, these radii, as long as it is the center, guys, look at, they met here and made 188. 88 rather. What am I doing? 188. Oh, okay. So they made 88 here. So if they go this side, they're going to make half of this, which is now 188 divided by 2. Finally angle PQR is equal to 44. Oh, degrees. I'm the one person who is particular about degrees. Okay. Then what else? Okay, we have this one. BPR. BPR. Just this small one here. BPR. How can I find this? BPR. 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 We're going to be in trouble. Oh yeah, there's 15 here. I wanted to create trouble for myself. Yeah, BPR. So this angle here. So now, if you look at this angle, and this angle here, they add up to 180. So now we have this 46, we have this 15, we don't have this one. But we can have this one if we say the angle between the radius and the tangent is 90. So here this 90 here. The whole this is 90. So if we say this one plus this one plus this one plus that one, is equal to 180 because these are angles in a triangle. So we are saying 46, this 46 here, plus 90, plus which one? Plus 15, plus this one, the one that we don't know. Okay, let's use y. Don't ask me why I'm using y, because of y is equal to 180. So 96 plus 46, that is 136. 136 plus 15 should be 151. Is it? Yeah, I don't know, but that's what my memory is saying. I don't know. 151 plus y is equal to 180. So y is equal to 180 minus 151. Y is equal to is it 29 or 39? 29. Yeah, 29. Yeah, it's 29. So this angle here is I'm starting right with 29, and I think this marks the end of this question. So 2 marks here, 1 mark there, and 1 mark there. You don't want to lose these marks. 4 marks under one topic, remain with 96. So guys, I hope you like this video. Comment what you think about it, then remember to share. And if it's the first time that you have watched one of my videos, there are plenty more. Please subscribe to this channel. Until next time, from me I say toodles.